Hey everyone, welcome back. Today we're going to look at complex fractions regarding rational functions. So if you've completed the previous rational function videos and the quadratics videos, today's lesson will be a lot easier for you. So here's an example of a complex fraction. Here we have fraction divided by fraction. So example 1, simplify. So here we have 2 plus 3 over x divided by 1 minus 4 over x. And the trick is you just deal with the top divided by, then you deal with the bottom at the same time. So here we need common denominator of x, so times x over x like that. Here we also need common denominator of x, so times x over x like that. So this reduces to 2x plus 3 over x, and this reduces to x minus 4 over x like that. Right, so we have this divided by that, so we're going to rewrite it like that. We're now going to go times the reciprocal like that. We notice that x over x cancels out, so what's left is 2x plus 3 over x minus 4. And the restrictions is x cannot be 0 or 4, like that. Right, and don't forget to look up here for restrictions, right? X cannot be 0. Okay, B. This can be rewritten as 1 over x minus 2 times x plus 2. So we're going to get common denominator. So here we're going to go times x plus 2 over x plus 2 like that. Here on the bottom, common denominator is going to be 5x. So here 5 over 5, here x over x like that. So this becomes 1 plus 2x plus 4 like that. This becomes 15 plus 2x like that. This becomes 2x plus 5 over x minus 2, x plus 2, times the reciprocal, so 5x over 15 plus 2x like that. Multiply 10x squared, 25x like that. Nothing reduces, and so our restrictions are 2, negative 2, 0 from up here, and this cannot be 0, and so that gives negative 15 over 2 like that. So these are all the restrictions. Okay, so practice number 1, simplify A, B. Go ahead and pause the video and answer that. Okay, we're back. A. Here we're going to have common denominator of x, so x over x like that. Here we're also going to have common denominator, so x over x like that. So this is 3x plus 4 over x. This is 2x minus 5 over x. Times the reciprocal. These x's cancel out. What's left is 3x plus 4 over 2x minus 5. Restrictions, x cannot be 0 or 5 over 2 like that. Okay, B. So here we want common denominators, so x minus 3 over x minus 3, and here x minus 2 over x minus 2. Here also common denominators, so x over x for here, and then x minus 1 over x minus 1 for here. So there's going to be a lot of multiplying. 3x minus 9, 2x minus 4, like that. Add that together with the common denominator, x minus 2, x minus 3, like that. On the bottom, we have x squared, 4x minus 4, like that, divided by x times x minus 1, like that. This is 5x minus 13 divided by x minus 2 times x minus 3 divided by this here, so x squared plus 4x minus 4 over x times x minus 1. So here we're going to go times the reciprocal, so we write that down like that. So here we have 5x minus 13 times x minus 1 like that. And so for restrictions, there's a lot of them here. So here can't be 0, 1, 2, or 3, as well as whatever makes this 0. So we're going to use our quadratic formula, right, to solve when does it equal 0. So here we have A equals 1, B equals 4, and C equals negative 4, like that. Little comment here, we get root 32. This can be written as root 16 times 2, root 16 root 2, which gives 4 root 2 like that. And we cancel 2 from each like that, so what's left is negative 2 plus or minus 2 root 2 as the two roots of this equation here. So we have negative 2 plus 2 root 2 and negative 2 minus 2 root 2 as part of the restrictions. And that's it. It's that easy. I'll see you guys in the next video.